This conference will now be recorded.
Okay. So only change I have to make is instead of this B, I have to set the direction of port B. So I have to write stress B here. And to make the changes into the port B, instead of port B, I have to make use of port D. So that was the program we finalized to turn on all 8 LEDs of port B or port D. Then after that, we saw how the template code generally looks like whenever we are going with any of our programming, how exactly is the template looking like. So first we will go with the initialization function. So all of the basic initialization, we will have a habit of writing it in a separate function called as the init config function. Is my audio not clear? Okay, can you check now? Am I audible now? Is it still echoing? Okay, fine. All right. Okay. So, fine. So let us continue. I was telling things with respect to the initialization, the init config function. So we are going to make it a practice to have all the initialization written in a separate function called as the init config function. Then after that, we are going to write the main function. But in case of main function, we will have a habit of taking the while of one, and all the logic, whatever is oriented to the application, we will have it return inside the while of one. And the reason is I want things to get executed for infinite number of times. None of the embedded systems will stop working after certain amount of time. So they have to run for their lifetime. So all the application code, I'm going to have it return inside while of one. Then I will write the main function separately, mean the header function, header separately called as main.h. And this is to make sure the header is included for only once, even if you are trying to include it for multiple times. So we have to start with the program's creation. So we discuss things with respect to the LED also, which is the very commonly used simplest feedback device. So that is going to work exactly like that of a diode, but emits light whenever current is passing through it. So very common places where LEDs are used is in the home lighting, in the remote controls, in the displays, and many more. So we saw the working principle of the LED. To make sure LED is being blown, you have to make sure that the LED is being connected in the forward biased connection. Positive of the LED have to be connected to the positive voltage. Negative of the LED have to be connected to the negative voltage. And there are two ways of LED being connected to the microcontroller. One is using the sourcing circuit. The other one is like a syncing circuit. So on our board, what we see is a sourcing circuit, which is why whenever I have to turn on an LED, what should I be providing at the pin of the microcontroller? So the corresponding pin of the microcontroller should be provided with the 1 whenever I have to turn on the LED. And to turn it off, I have to be providing a 0. And whenever LEDs are considered, okay, so whenever I'm going to program the LED, what should be the direction of the pin which is connected to the LED? So what should be the direction of the pin always when an LED is connected to a pin of a microcontroller? Should it be treated as an input pin or should it be treated as an output pin? Yes, so always whenever LED is being connected to a pin of the microcontroller, you have to treat it as an output itself. Because to the LED, the pin is serving as an input, but with respect to the microcontroller, it is giving out a 0 or a 1. So pin direction should be output whenever LED is being connected to the pin of the microcontroller. So this much we finished yesterday, and today we have to start with learning the usage of the tool. So we will start doing the tools usage from today, and we are going to make use of the same throughout the module. Now, wherever you want to have your programs typed, we are going to make use of IDE, a development tool called as the MPLabX IDE. So I'm going to open it, MPLabX IDE. So right now I'm using the version 6.10, and I'm not sure which versions you have downloaded, but all the versions have not reported any issues as such. So some of the user interfaces is quite different, but apart from that, functionalities are going to remain the same. So if you have downloaded a lower version, it is fine. If you have downloaded a higher version, then also it is fine. So my version I'm using is 6.10. So this is the MPLabX IDE, which I have installed in my device. So it takes a while to get loaded. So once the IDE gets opened, this is the start page you get to see. So you will not see this, one second. Okay, so one second. So you will not get to see any of this project. I'm trying to close it. So generally, it will be a little slow comparatively, but you don't have to worry. So this should be the main page which gets seen when you have just opened the IDE. So let me briefly tell you what and all this IDE has as an outlook initially. To start with, here you will get MPLabX IDE with its version. So mine, as I said, is 6.10. So at the top left corner of the screen, there is IDE along with the version, which is 6.10. Then what you have is the menu bar. Okay, so whatever you have got, the file, edit, view, navigate, source, refactor, production, debug, team, tools, window, and help. So they all belongs to the menu bar. Then below that, what you see is the tools bar. Okay, so you have multiple tools available here. So whatever you are seeing below that is the tools bar. And after that, on the left hand side, you will see a window for the project. So whichever project you are working on, that project gets displayed here in the project window. So as of now, we don't have any of those projects opened or being used. Hence, you can see a blank screen here. Then this, what you see, the start page is the editor window. So that is where you will edit the files, open the files, view the files, do modification into the files. So we call it as an editor window. So whatever files you have got in a particular project, you can edit it being in this editor window. Then below that, if you see, there will be a blank screen. I don't think you will see an output screen. So this will not be there. The output screen initially will not be there. But even if it is there, it is fine. So below that, you can see some of the projects already available. Okay. Yes. So some of the windows might not be available in your case. I will show you how to go for that windows. So first, let me briefly tell what happens in this page. So in the start page, you might be seeing some projects which has some options like sample project, create new project, import legacy, and import pre-built. So that is like the common option. Even everybody must have been seeing it. So there, if you want some sample projects, you can open them. If you want some project to be created, you can click on it. So if you want some legacy to be imported, some pre-built things to be imported, you can import it here in the projects. Then below that, you can find the data sheets. So whatever data sheets are available for a microcontroller or for a particular peripheral, so multiple data sheets will be available. You can click on it and you can get the data sheets also. Then there is something called as programming center. Then after that, you have recent projects. So there it will actually show the list of the projects you have been working previously. In your case, it will be an empty field. In my case, I have opened several projects few days before, so I can see the list of the projects whichever I worked on. Then after that, you have an option of microchip login also. So if you want, you can create your own microchip account to use this tool, but I wouldn't suggest which is necessary. Okay, so it is not really necessary to have any login created. You can use a non-login based IDE directly, so you don't have to use it. So if you are not finding any of these, don't worry. Okay, so is it open source to access that particular page? Which page are you asking for as an open source, Babu? The microchip login, that is like you can have a login created, you can create your own account for the microchip, but 99% of the functionalities are available for non-login also. Okay, so like very advanced features, if you want, you may have to log in and take a user account and then use the IDE. But as far as we are working on, so we don't need any dependency for the login, so we are not going to like create a login ID. That is not necessary. And for those whoever are not getting any of these windows, so you can just click on Windows and it will show you the list of the windows available. Okay, so whatever windows you want, you can have them selected. There's project window, there's files window, classes window, favorites, then dashboard, navigator, task, editor, debugging, simulator. So many of the windows are available here. So if you're not getting any of these windows, you can bring it with the help of the windows here. Okay, but what we majorly want is a project window at the left here, a start page at the right here, and after you execute, there has to be an output window at the bottom. So that's the maximum I want throughout the module. A project window on the left, a editor window on the right, and after I write some program, you will have one output window here at the bottom. So rest of all other things is least bothered. So we will not be using any other functionalities. All right. So now let us start creating the project of our choice. So we have to write the program here. The cross compiler is available in this IDE, and that is going to convert whatever program you have written into an executable file, which you can later execute it on the microcontroller. Okay, so let us start. Uh, there's a doubt. I have a doubt. GC, somebody's microphone. Anirudh. Okay. So GCC doesn't have a cross compiler. That's why we are using it. No. So it has its own cross compiler also. So that is AVR GCC. Somebody's mic. Anirudh. Okay. So is it fine now? Yeah, so I was saying GCC has its own cross compiler also, that is AVR GCC. But that cross compiler is not sufficient for our operation. So that was not supporting most of the microcontrollers. So we chose to take X8 cross compiler. So it completely depends whichever cross compiler you want to choose. Ours is X8. Okay. All right. So let us begin. To start with, you always have to create a project while you want to perform some operations. You want to create a project all the time, and you have to get an executable file generated from this IDE. That executable file, you have to put it in the microcontroller and execute. So to start with, to create a project, you have to go to File and click on New Project. So one way is you can go to File and click on New Project. Okay. Apart from that, if you want, you can click on the second icon on the tools bar that also represents new project. So either go to file, new project, or click on the second icon on the tools bar. It is going to create a new project. Now it is asking me the category. It's microchip embedded. The category has to be microchip embedded. And the project we are going to create is a standalone project. Okay. So it is a simple standalone project. So categories is microchip embedded. Project is standalone. So once you have selected this, you have to click on next. So first categories is microchip embedded. Project is standalone. Click on next and you should be moving to the next. So here the family you are going to work with is a 8-bit microcontroller. So instead of you selecting the whole family of microcontrollers, this IDE supports multiple microcontrollers. So ours is a 8-bit range, 8-bit, mid-range 8-bit MCUs. So you can see there is PIC 10, 12, 16 and MCP available. So I'm going to select it. Okay. So family is mid-range 8-bit MCUs. The device is our microcontroller. So if you want, you can scroll down here and select for the microcontroller. But I feel it is easy to type rather than finding it there. So I will type PIC16F877A microcontroller. So once I properly type it, I'm going to select that microcontroller, the PIC16F877A. So the family has to be mid-range 8-bit MCUs and the device has to be PIC16F877. And tools as of now don't make any changes. So we have not incorporated a tool into the IDE already. So you don't have to be worrying about the tool. So only you have to select family, then you have to select the device. Do not touch the tool. Once you're done selecting the family and the device, you have to again click on next and it will ask you to choose the compiler. Now, if you have properly installed the XC8 cross compiler, you will get this option called XC8 version 2.36 and also its path where the executable file is found. If you have not installed the compiler properly, then you will not get it identified here. In that case, you have to reinstall the compiler. So I am using the XC8 cross compilers version 2.36. So I have selected that compiler. Okay. Now after selecting the compiler, I am again, okay, version varies, it is fine. So version of the compiler being different is fine. Okay. So I'm going to proceed, but you have to get the XC8 identified. After you click on the compiler, the cross compiler XC8, please click on next. So it will take you to this particular page. And this is the final page which you have to properly take care, because once you are done with this page, you will not be able to make any changes to the project later. The default things, whatever are being set, so whatever we previously set, you have to make sure it is being properly done. If you want, you can go back and check. But once this step gets completed, you will not be able to again do any changes in the basic settings. First, you have to give the project's name. I'm going to keep it as LED. Okay. So I am keeping it as LED itself. Can you go back and show what is before selecting the compiler? Before selecting the compiler, the microcontroller family has to be mid-range 8-bit MCU and the microcontroller has to be PIC16F877A. Okay, and tools should not be touched. Keep it untouched. Okay, so I'm giving the project's name as LED. Okay, once you're done giving the project's name, the project gets created in a default path, what it shows in your device. So in your device, it must have been under desktop, under program files, microchip, something like that. So it will be a path where all of your projects will be found later. But if you want, you can direct it into a specific directory also. So in my case, I will store it into a directory of your batch name. So under desktop, under MC class, under 23011. So that is my path. I want all my project to get stored in this path. So I have browsed the path. If you don't want to browse the path, you can remember the default path where the project will be stored. So once you give the path, you will see the project's name with .hex extension. Okay, the same path with project name and .x extension. Now don't make any changes after this and click on finish. Okay, so not making any changes, you're clicking on finish. So now a project gets created. So you can see a project window on the left hand side by the name LED. Okay, there will be a project name by the name LED shown on the left top window. It has multiple sections like header file, important file, linker file, source file, libraries, loadables and all. But if you want to confirm whether this project is created or not, you can go to that particular path and check. So let me show. Under desktop, under MC classes, under 23008 plus 11, you can see this project. So the name of the project is led.x. It has got created in the path I have specified. So you will also be able to see that project created in the path whatever you have specified. Understood up to this? Everybody, is this clear? Okay. Now let us go add some files into this. Okay, so we are supposed to add some files. So on the left hand side, if you see, under the project LED, okay, so under the project LED, I have got multiple options. Okay, the options are header files. So all of the header files you create will come here under header files. All of the important files, whatever is required, comes under this important files. All of the linking files, whatever linking files you need, they come under this linker files. All of your source files means what kind of files do you think? What is a source file? What will be the extension of the files which come under source files? So all of your .c files, yes. So all of your .c files are called as source files. So those source files will come under the source files section. Then libraries, whatever libraries are required for the project gets returned here. And loadables will have all the executable file return. Okay, so loadables will have the executable file return. So these are the sub directories, or I would say subfolders, which will be available in the project you have created. So I can show you that header files will have only the header files return. Important files will have some necessary files return. Linker files will have some linking things. For example, make files and all gets returned. Okay, make file is under important file. So linker file will have any linking file required from one project to another or from one file to another. Then source files will have your .c files. Libraries will have your library files added, and loadables will have your executable file. Now to start with, I want to add a main.c file. To which section do you think I should be adding this? I want a main.c file to be added. So to which section should I be adding the main.c file? Yes, it has to be under source files. Okay, so under source files, we are going to start writing the project. So I have to create a main.c file. So you have to go to source files and do a right click, and I have to select new. So click on source files, right click and select new. Now you will get multiple options here. But are you able to see main.c? Are you able to see a file called main.c? If yes, please click on it. Okay. If no, people can go to other, or people can select C source file. So you either can go with main.c, or you can select C source file, or you can go to others. In others, you can click on C here, okay, and C source files. So any of the way you can choose. Let me show it again. Right click, new. If there is main.c, click on main.c. If there is C source files, click on C source files. Else go to others and click on C. You will get an option of C source file. You have to click on next. Now I have the option of main.c. So I'm going to open my main.c. The name of the file has to be main always, okay, and do not make any changes. So file name has to be main. Keep the extension as C itself. Do not change this. So only file name you have to take it as main. And after this, you can click on finish. Okay. So file name you have to take main. Keep the extension as .c itself. Okay. And then you're going to click on finish. After this, you will get a main.c file created. Can you please check and tell me, is this how your main.c also looks like? Is this how your main.c is looking like? Have you got the same contents written in your main.c also? Yes? Surprisingly, you're saying this the same static void init config, the main function like this? Okay, some of you will none of you should have this. In fact, none of you should be having this. Okay, so you have only void main and return. Okay, fine. Now, please understand, this is the one we are going to follow throughout the module. Okay, we will have init config function return like this. We will have void main return like this. Init config function call while of 1. So this is how my main.c file should look like throughout the module. That is why we will create a template. Okay, we have to create a template. How to create a template is, you have to click on tools and you have to click on templates. So click on tools and click on templates. Now in this, you have to select microchip embedded. Okay, so you have to select microchip embedded. You can expand it by clicking a plus which is behind it. Okay, so under microchip embedded, it has to be XC8 compiler. Under microchip embedded, it has to be XC8 compiler. Again, click on plus. There, you will see the option called main.c. You just click on main.c for once and select open in editor. Okay, so select open in editor. Now, I'm going to share the contents in your chat box. Okay, please remove whatever your main function has or your main.c has, and please paste the new code which I have just sent. So delete all the previously written main function and please paste the new main function I have sent. So there has to be nothing else apart from what I'm showing on my screen. Please make sure you're not writing two main functions. Okay, I'm repeating again. Please make sure you're not writing two main functions. So first has to be your documentation part. Even if it is not there, you just leave it. Your main.c file should have only this much what I have shared. Don't ask again that your program or your main.c file has two main functions. That is not right. So you just copy paste it with whatever I have sent. And once you are done doing this, you have to save it. You can either use Control yes, or if the save option is enabled here, the fourth option is save. So in the tools bar, fourth option is save. If that is enabled, you can click on that. So either of the one, Control yes or the fourth option, you have to click on save. Okay, so I'm repeating how to go to this. First you have to go to tools, then you have to go to templates, then under microchip embedded you have to search for XC8. Under XC8 you have to click on main.c and you have to click on open in editor. You will get a new main.c file. Okay, so in that please paste whatever I have given you in the chat box, save it and close it. So to close, you can just use this X mark beside the file. So close both the main.c files. Okay, so I'm closing. Observe both the main.c files. This one I'm closing, this one also I'm closing. But your main.c file under source files will still be there. You have to delete it. When you right click it, you don't have an option to delete. There is only option to remove from the project, but it will still be there in your project. So it will not get deleted. If you want to delete this main.c file, once you have clicked the main.c file, you can use the delete key on your keyboard. So press delete key on your keyboard. It says the file will be permanently removed from the system. Are you sure you want to delete main.c? So I will say yes. So you have to click on main.c and use the delete key and click on yes. Now again add a main.c file. Go to source files, right click, new main.c. So give the name as main. Okay. Extension has to be C itself. So click on finish. Now the main.c file you are creating should be exactly same as that of mine. Can you please confirm? So now the main.c file which you have got should be exactly as that of mine. Even if there is a slightest change between the two, okay, if there is even a slightest change observed according to my program, then yours will not work fine. So please make sure it is working, it is written exactly as you see in my main.c file. Okay. Okay. So I hope this much is done from all of your side. So now I will have my program return. Okay. So whatever initialization I want to do, I will write it here in the init config function. So first one is first one is tris B. I have to write it to with 0x00. Then initially I want all my LEDs to be turned off. Okay, basically when the program has just started, I want all of the LEDs to be turned off. So I will write port B with 0x00. Okay. So what this trisb will do is set RB7 to RB0 as output. And what will this do is initially turn off all 8 LEDs of port B. Okay, so that is what we have done. So initially I'm going to turn off all 8 LEDs of port B, and I am going to set RB7 to RB0 as output. Then coming here, I have to turn on all 8 LEDs of port B. So I'll write port B with 0B 1111 1111. Or if you want, you can write 0xFF also. So both of them are doing the same job. Now after you are done writing your program, you have to save it. So you can either save it using Control yes, or you can save it with the fourth option called save. So here in the tools bar, your fourth option is save. So you can save. Okay. Now once I'm done saving, I have to execute it. Okay. Once I'm done saving, I have to execute it. Where should I be executing this program? Where should I be executing this program? Come on, whatever program I'm going to write, where will I execute it? Yes, on the PiximLab board, especially on the microcontroller, which is available on the PiximLab board, correct? So I should execute this on my microcontroller. But actually, before executing it on my microcontroller, if you want, you can debug the code. Okay, so before running it on your microcontroller, because there might be some problem in your program which will damage the microcontroller. So you actually can debug and check if the code will be working fine. So we will not be doing it for every program, but I will show you how to debug it. Okay, so debugging means it will run the code line by itself, and it is going to show me whether the line is going to work fine. Okay, so I have to be debugging the code. Now before I start debugging the code, have you ever seen this line number 11? This ash pragma config wdt is equal to off. Did we ever speak about this line? No. So we don't know it. So let me comment it. Okay. So I'm going to comment it. Ash pragma you know, but this line exactly you have no idea. So I'm commenting it. Now I want to check. Please save. Okay. I want to check whether my code will be working fine or not. So you can choose to debug your code. So you can select this option. Okay, this option. So beside that option, there is a small arrow hidden. You please click on it and select the first option. This is only for debugging. Okay, and we will not debug it every time. So only for the first time I'll be showing it. This is for debugging. So build for debugging the main project has to be selected. Okay, so click on this icon. Okay, and you have to scroll down. By default, if you click, it will take debugging itself. So better option is you scroll the arrow which is next to the option and select build for debugging. Now once you're done debugging, you will get an output window which shows build is been successful. Did you see that? So once you have selected the debugging, you should get build is successful. If there are any errors, it will be listed here. If there are no errors, it says build is successful. And along with that, it also tells how much space it has used and how much time it has used. So to build this, it took approximately 12 seconds of time, and the space it takes is, you can see in the program space of how much it is, 8 bytes. Okay, approximately 8 bytes are being used. Sorry, 2000 words are being written. So 170 hexadecimal bytes have been written, 100 hexadecimal bytes. So it shows how much memory is being used in each space. So it shows the memory summary also. Then it also shows the time it has taken to build. Okay. So to debug, you have first, I am commenting this pragma config line. Then you have to scroll next to the debug option which I have highlighted here, and you have to click on build for debugging the main project. So you will get build successful if there are no errors, and you will get to see the total time it has consumed and total memory it has occupied. Okay. Now assume you don't have a hardware. You want to check if it is working fine or not. You have to use the debugger. So you have to select this now. Okay, let me highlight. You have to select this which represents debugging. Okay, so you have to select this which represents debugging. When I click on it, okay, so I am going to click on it. So when I'm clicking on it, it is saying tools not found. Okay, in that case, you please scroll down and select a simulator. Okay, so you have to select, once you give the run option here or debug option here, so it shows a pop-up saying tools not found. So scroll down the arrows and select simulator and click on OK. Okay. So now after few seconds, this project, whatever you have created, will start executing. So the project which you have created will start executing. It again shows build is been successful. Loading is completed. One more window gets opened called as the debugging window. Okay, so give me a second, it is just loading yet. Okay, you can see there is a debugger console and also a simulator. Okay, there are two things. So two more window in the output itself, two more window got added. One is debugger console, the other one is simulator. Debugger console says launching is done, initialization of the simulator is done, and user program is running. Okay. In the simulator, if you see, it has resetted all the special function registers. It has resetted all the peripherals, and the code is actually running. But after that, can you see a message which keeps saying watchdog timer has caused a reset? Can you see that watchdog timer has caused a reset? That is because, please understand, every microcontroller comes with a timer called watchdog timer. Okay, so WDT stands for watchdog timer. Now, what is this watchdog timer used for is? This is to reset the board on a regular interval. Okay, reset the board on regular interval. So a very commonly place where we are going to use the watchdog timer is if you are trying to design an embedded system for the remote applications. The remote applications in the sense you are having an embedded system designed in some remote area. You cannot literally go and reset the board again and again. So that is not possible. So whenever you want to reset the board, okay, of the particular microcontroller which is placed in a remote location, you will enable the watchdog timer. The watchdog timer is a timer which is used to reset the board at the specified amount of time. Now the problem with our microcontroller is the watchdog timer has been set to 1 second. Okay, so the watchdog timer has been set to 1 second. So for every 1 second, my board is been getting reset. Okay, for every 1 second, my board is getting reset. Now, if for every 1 second you will give the reset button, do you think it gets time to execute the code you have written? If the board is getting reset for every 1 second, will your board get time to execute the code? Obviously, no. So I have to stop this watchdog timer, okay, which is running on my microcontroller. I have to basically stop this watchdog timer. Now, how to stop this watchdog timer is you have to go to production, okay, you have to go to production, set configuration bits, okay, you can see here WDTE watchdog timer enable bit. It is initially on, you have to make it off. So that is when watchdog timer will stop. It is going to get turned off. Now your code runs normally. Okay, so this time your code has to be running normally. So if you see that message will not get printed afterwards. After this, I will not get that message printed again and again. So my code will get its time for the execution. But observe, I'm going to stop this. Okay, I'm repeating again. Please listen to this carefully. So I'm talking about a line called as the debug. Okay, so sorry, I'm talking about ash pragma line. So assume I don't have any program, I don't have any hardware. I cannot take my code and execute on the hardware directly. So I want to check if my code will work fine or not. So I will build, I will debug. So I'm going to run the debugger. When I start to execute, so it asks me to select the tool. I selected simulator. So when the program is running, it will launch two more windows. One is debugger window, the other one is simulator window. So debugger window will say it has launched the simulator and the program is running. Simulator will actually let the line by line execution of your program. Now it keeps saying watchdog timer has caused a reset because by default your PIC microcontroller has a watchdog timer which keeps resetting the board for every 1 second. So for every 1 second it is keep resetting the board. Now because it is keep resetting the board for every 1 second, your controller will not get sufficient time to execute the code. So what I have to do is I have to turn off the watchdog timer. So I have to go to production, click on set configuration bits. I have to select WDTE and I have to turn it off. So that is how you stop the watchdog timer. Now I will stop debugging. So this here should be used to stop the debugging. Okay, I will stop the debugging. Let's say I make some changes into the file. I save it. Then again I have to build for debugging main project. Okay. So I'm going to build for debugging main project. And once the build is successful, I will again start the simulator. I will again start the debugger. So I'm clicking on this. Okay. So I have to get a debugger console and a simulator console given. Now see, again if you observe, can you see the message has been displayed again? I just turned it off previously, but can you see a message being displayed again? That is because if you look at the configuration bits, see, it is again on. So the problem with this is you have to go turn off this watchdog timer every time you are going to run your code. So you have to explicitly go and turn off this watchdog timer every time. But this is obviously time consuming. So I will turn it off and click on generate source code to output. When I clicked on generate source code to output, I will get the code to turn off the watchdog timer. Okay, so observe once again. When I clicked on generate source code, so I got this line ash pragma config wdte is equal to on. So that was for watchdog timer being on. So make it off and generate the source code to output. So you will get ash pragma config wdte is equal to off. So I copied that line and I have just pasted it here. That is because I want to turn off the watchdog timer initially. Understood this? Understood why did we write this line? Okay. So once you're done with this, please stop the debugging. Okay. Stop the debugging here. Do not forget to stop the debugging. If you don't stop the debugging, it will not get an executable file generated. So here onwards, whenever you want to debug your code, you can use the debugger, but we will not be using it. So I just wanted to show this lines usage. So I made use of a debugger. So we will not be using any debugging tool going ahead. Okay. So now getting back, let us see the output now. So after you are done making changes to the file, I have uncommented this. I have removed the comment I wrote. Now I have to build this project to execute. So again scroll down here and please select build main project. Okay, scroll down and select build main project. File is taking too much of time to load. Have you stopped debugging here? So here, if there is a red icon seen, please stop it. You click on it. So that will stop the debugging. Okay, are you following? So it's like even after that, if it is taking too much of time, then I can help it because maybe the processor is slow. Okay, so either the processor is slow, or I would say you already have too many things in your file. You can free up the memory a little. Okay, fine. So whatever I did previously, you need not do it again, because anyways, this line in your code is performing its operation. So you don't have to do it. I'm just showing you that this is the scenario which you may have to deal going ahead. So turning off the watchdog timer for any of a controller is necessary because it keeps resetting the board. So to turn it off, you have to first go to production and click on configuration bits. So here, set configuration bits. Then watchdog timer has to be off here. And after you make it off, you have to select generate source code. So that is going to give me a line for the watchdog timer. I copy it and have it return in my file. But anyways, in the template, we have already returned that file. So you don't have to do it again and again. Okay. So those who are still debugging, please make sure you're stopping the debugging here. There will be a red box seen. You please click on it and stop the debugging. Default option is there instead of WDT. Of if you want the reset to be done, you have a button on your board. So as of now, we are not working on any remote project. So you have a reset button on your board. Whenever you want to reset the board, you can click on that reset button. Okay. Fine. So let us continue. So to start with, as I said, once you are done writing your code, please go to this arrow, okay, which is next to the build, and please click on build main project. Now, once you give build main project, okay, in your output window, after there is build successful, you have to see a path like this. Your project name, distribute, default, production, and a hex file at the end. So only if you get this, then you have got an executable file generated. Please confirm if you are getting this. The path has to be whatever previous path you have selected, it has to be there. Then you have to get the name of the project, distribute, default, production, and the hex file. Please, if anybody is still doing this, please confirm if you have got the hex file. Okay, got it. When did the same options came, but still, when did the same options came? Your file is still loading. Okay, let it take its time. Okay, and also Muskan, check with the compatibility of the IDE with your device. So some of the IDEs will not be working fine in all of your Windows version. So please check with the compatibility ones, and then if that is not the proper version to be used in your device, you can downgrade it. You can get a lower version of it installed. Okay, but if you are okay with that, it's fine. Okay, so fine. So I hope all of you got this distribute, default, production, and the hex file. So this is the path where your executable file is found. Okay, you have to remember this path. Okay, so all of your executable file will be going to the same path. In my case, it is users Lenovo desktop MC class 23008 plus 11, the project name, distribute default production, and the hex file. So your cross compiler gives a hex file as an executable file for your particular project. Okay. Now, once you're done getting the hex file, so I have to execute this code. So I got the executable file also. I just have to put it on my microcontroller and see the output. So for that, first you have to open PixInLab board. Okay. So you first have to open the PixInLab simulator. So this is your board. You have to go to the required board. So first under board, you have to select PicGenius. Under microcontroller, you have to select PIC16F8778. So please make sure you are choosing the proper board and the proper microcontroller. So PicGenius PIC16F8778 should be displayed at the top left corner of the board. Okay. Now you have to load that executable file to your microcontroller which is available on this board. Okay, you have to load the program, the executable file to this microcontroller on the board. So you have to click on file and click on load X. Okay, click on file and click on load X. Now you have to use the path what it showed here. So this path you have to use. Okay, so I will follow the same path. Observe. Move it a little here. Okay, so I will follow the same path. See, file, load hex. See the path in the C drive. So I'll go to C drive. Then I'll go to users. Then Lenovo. Then I have to go to desktop. Then MC class. Then 23008 plus 11. The project, distribute, default, production, the hex file. Okay, you have to follow this path. So generally up to this will be the path what you have specified to have your project. Then after this will be a common path generally, the project name, distribute, default, production, hex file. So I have loaded the hex file. Now if you have loaded the hex file, are you able to see the LED turned on in port B? Is there anybody who can see LEDs turned on in port B? In my case, it is actually port D. It is not port B. So this second set of LED has to be turned on. So is it turned on? Okay. For those whose LED is not turned on, let me tell you one more thing. So there is something called as DIP pin. Okay, so this what I'm highlighting is called as a DIP pin. Do you remember that I said the pins of the microcontroller are multitasking? So did I say some of the pins will be RB0, then it may perform another task also. So you have to tell your microcontroller that whatever port B is there, please use it for the LED. So this first one, what you see, okay, on one side there is LED2, On the other side, it is port B. Okay. Now, if you want LED 2 to be used, the DIP has to be opposite to that. Okay. So, see, if I want LED to be used, okay, the pin, the switch what you see should be opposite to it. So, you just click on it, it will go opposite to that. Now, are you able to see the LEDs turned on? So, the switch here should be towards port B and opposite to LED 2. Now, if B0 is not turned on, there is a third DIP. Okay. So, there is this third DIP which is representing RB0. Can you observe that? Can you observe that the third is RB0? Please put the DIP against it. You want RB0 to be used? Put opposite to that. Okay. So, you should be able to see port the B0 also turned on. I want LED to be used. So, I have put it on the other side. Okay, so I hope you are following it. If you want LED to be used, so your DIP should be opposite to that. If you want RB0 to be used, your DIP should be opposite to that. So you should be able to see all 8 LEDs of port B turned on. Are you able to follow this? Okay. Now let us write one more program. Why D is on? That is because of some garbage value being returned on port D. So I have returned some garbage value on port D earlier. So due to that, the LEDs are glowing in my case. It need not be glowing in your case. Okay. So, all right, let us write one more program. I have to toggle LED on port B. So that is the program. So I have to toggle LEDs on port B. Means all 8 LEDs have to be on. Okay. Then all 8 have to be off. Again, all 8 have to be on. Again, all 8 have to be off. And this has to continue. So you have to toggle all 8 LEDs which are connected on port B. So first they have to be on, off, on, off. All 8 LEDs has to be on and off. Let us write the program. First I will write the init config function. Can you tell me what to write in the init config function? What should I write here in the init config function? Yes. So I have to write trisb is equal to 0x00. This is to set RB0 to RB7 as output. Okay. So this is to set RB0 to RB7 as output. Next, basically let me turn off all 8 LEDs. Okay. So to turn off all 8 LEDs, what should I write? Basically to turn off all 8 LEDs, yes. So port B, I have to write with 0 or 0x00 or just 0 or 0B0000, that also can be written. I will write 0x00. That is to turn off all 8 LEDs. So first to set the direction, I'm writing trace B is equal to 0x00. Then to turn off all 8 LEDs, I'm writing port B is equal to 0x00. Then main function, so void main, this is also void. Then I have to do the init config function call. Okay, next I have to write while of 1. Now being inside while of 1, first I have to turn on all 8 LEDs. So how to turn on all 8 LEDs? Turn on all 8 LEDs. How to turn it on? Okay. So I have to write port B is equal to 0xFF. Okay. Next, I have to turn off all 8 LEDs. So turn off all 8 LEDs. Okay. So I have to write port B is equal to 0x00. So I'm turning it on, I'm turning it off. Again you come inside while of 1, I'm turning it on, I'm turning it off. Again you come inside while of 1, I'm turning it on, I'm turning it off. Can you help me merge these two statements together? Can you help me merge these two statements together? I want to turn it on, I want to turn it off. So help me merge these two statements. Toggle, what toggle? Toggle this. Yes, so it has to be port B, complement of port B. So here I'll take complement of port B. Okay, see what happens. Initially port B is written with the value 0000 0000. What is complement of port B? Complement of port B will be 1111 1111. So port B is written with all ones. Then again you come back here, what is complement of port B? It will be 0000 Again complement of port B 1111 1111. Don't you think I'm turning all 8 LEDs off, all 8 LEDs on? Am I not doing it? Yes. But there is a small problem here. I have written this inside while of 1. Turning on, turning off, turning on, turning off, don't you think happens on a very fast manner? I have written inside while of 1. Yes, so everything is going to happen on a very fast manner. Okay, it is literally happening on a very fast manner. Now I have to create a delay. You cannot put your microcontroller to sleep. Don't make your microcontroller sleep. And you have no idea how to put it to the sleep mode yet. So let me just kill some time. I want to create a delay. So to create the delay, I already have a built-in function, but I will not use that built-in function. Instead, I will create a delay like this. For, okay, let's say int I is equal to around 50,000 I minus minus like this. Okay, so this is what I'm doing. I have written a for loop. Int I is equal to 50,000 I minus minus and nothing here. So how many times is this loop running? How many times is this for loop running? Look at this and tell me how many times is the for loop running? Only one time? It runs for 50,000 times, right? So only when 50,000 only when I minus minus will be 0, you come out of the loop. So the loop is running for 50,000 times. And inside the loop, I'm doing nothing. So I'm just keeping my control busy in executing this for loop so that in the hardware I get time to see the output. Okay, I'm just killing the time of the controller. Your controller will be busy executing this for loop. In the hardware, I will get the time to see the output on the LED. So I have taken a for loop here, and that is for the sake of delay. Okay, so that is it. We are done with the program. Let me make changes into the file here and execute it and check. So this is the only change I have to make here. Okay, and in fact delay is very small. The 50,000 I have taken is in fact very small, but still let me show you the output. Okay, so let me execute it. Okay, so I'm going to save it. Okay, whatever changes you made, please save it. Then you please go to this build and click on build main project. It is not debugging, it is build main project. Now it has to build the main project, but assume there is, look at this, there is a warning. What the warning says is implicit conversion from long to integer. So I have taken 50,000 here. Integer I was 50,000. Tell me how much is the size of integer in case of your GCC compiler? How much is the size of integer in the GCC compiler? It is 32 what? 4 bytes, is it? So size of integer is 4 bytes in case of GCC compiler. But in case of XC8 cross compiler, the size of integer is just 2 bytes. Okay, size of integer is just 2 bytes. So if you take unsigned integer, you can store a value of 0 to 65535. But what I have taken is a signed integer. So signed integer cannot even store 50,000. So I will take this as unsigned integer at least. Okay, unsigned integer. Now again save and build this. So build main project. So build has to happen. Okay, so build is going on. Build is being successful and loading is completed. This is where the hex file is found and I don't see any warnings this time. Now after the hex file is generated, go to the Pixim lab, go to file and do load hex. Actually, if the previously loaded path is same as that of the new path you are going to load, you can just directly do reload last. Okay, if the previously loaded path is same as that of the new path you want to load, you can click on reload last. Can you see the toggling of LED? On, off, on, off, on, off. But that is still happening on a very faster duration. So you can still increase the delay. I will go with unsigned long integer and I will assign it with 1 lakh. Okay, so I will assign it with 1 lakh. So now again save, then build the main project, get the executable file generated and go to the Pixim lab, go to file and reload last. This time, I think you are able to see the proper output. So off, on, off, on. How to load the hex file? You have to go to file and click on load hex. You have to follow the path which you get here. Okay. So under 23, okay, under desktop, MC class 23008 plus 11, LEDX distribute default production hex file. So under desktop, MC class 23008 plus 11, hex file, distribute, default, production, the hex file. So that will load the hex file to your project. Following this? Any doubts? Okay. My next task is, first I should have first 4 LEDs on, then I should have next 4 LEDs on. Okay, something like this. Observe. First I want these 4 LEDs to be on. Next I want the next 4 LEDs to be on. Can you tell me how to do it? I want to turn on first 4 LEDs. Then I have to turn on next 4 LEDs. Means alternative 4 LEDs have to be turned on. Okay. So initially port B has to be returned with 0xF0. That's it. Okay. If you write initialization with 0xF0, so 0xF0 will be 1111 0000. Its complement is 0000 1111. Then again its complement will be 1111 0000. Again its complement will be 0000 1111. So like this it can work. Observe, I will save. Every time you make the change, you have to build the project. You have to get a new hex file generated and you have to load it to your microcontroller. Okay, build is been successful and loading is completed. I'll go here and do the file reload last because previously loaded path is same as the new path. So I do the reload last. Can you see the output? I'm getting this error, make one build error, build is failed. Okay, so that is because maybe your ID sometimes will not work fine. So you just close your ID and relaunch it. Okay. Next I want what is inbuilt in function for delay. You will see it later. Please have patience. Okay, next one. I want alternative LEDs to be turned on. So I want a B0, B2, B4, B6 for the first time. Then I want B1, B3, B5, B7. So how to do it? Yes. So initially you have to write it with 0B or I can, 0X So A is 1010, 1010. So alternative LEDs will be turned on. Okay, so I'm building here. So let us wait till the hex file gets loaded. I mean, build is getting completed, then we will proceed. So I can go to file and reload now. So can you see the alternative LEDs? Okay. Please note it down. Take a break of 2 minutes. We will do one class work. Okay, done. Can we proceed? Okay, so let us do a small class work, one small class work. So the thing is, I want to turn on the LED one after the other. So that means I have to first turn on the LED at B0, then I have to turn on the LED at B1, then B2, then B3, B4, B5, B6, B7. I hope you are getting my question. I want to turn on the LEDs one after the other. And whatever previous LEDs I have turned it on, I have to keep it on itself. So first, to turn on the first LED, which is at B0, what should I use? What should I write to the port B? To turn on the first LED. Yes, it is 0, 0, 0, 0, 0, 0, 0, 1. Then to turn on the next LED, what should I write? To turn on the next LED, should I write it too? I'll write 0, 0, 0, 0, 0, 0, 1, 1, 1. Okay. So for the next LED, I want the previous LED also to be on and the new LED to be on. Then the next LED is 0, 0, 0, 0, 0, 1, 1, 1. Then 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 1, 0, 0, 1, 1, 1, 1, 1, 1, 0, 1, 1, 1, 1, 1, 1, 1, and 1, 1, 1, 1, 1, 1, 1, 1. Now tell me how to write this. Left shift for 1 plus 1 will not work. So if you do left shift for ones, so first, okay, first two will be fine. Okay, that is possible. Left shift for 1 plus 1. Yes, it is possible. So port B or with 1 left shifted for 1 times. Port is equal to port plus 1 will not work, guys. Port plus 1 is not right. Port B left shifted for 1s plus 1. So instead of using arithmetic operators, can you tell me without using arithmetic operators? So actually what Divakar says, port B is equal to port B or with 1 left shifted for 1 is like quite different. Port B left shifted for 1 or with 1. Correct. That will work. Okay. So let me take here. Okay. So port B is equal to, this has to be port B left shifted for 1s. Okay. Or with 1. So this should be working. You can trace it. So port B left shifted for 1s or with 1. Let me increase this. So I'll take 1,50,000, okay, as a delay so that I'll be able to see the output. So port B is equal to port B left shifted for 1 or with 1. Okay. Now how many times do you think this has to happen? How many times this has to happen? So this should happen for 8 times in fact. The code what you have written is I have 8 LEDs and I should be making this work for 8 times only. Beyond 8 times it is not good to do it. So I take one more for loop. Okay. So for I, let's say character j is equal to 0, j lesser than 8 and j plus plus. Okay. So inside this, I will perform this operation. I hope you are able to follow this. So I'm doing this operation for 8 times only. Okay. So port B is equal to port B left shifted for once or with one time. So initially I will have 0, 0, 0, 0, 0, 0, 0, 0. Then I left shift this for ones or with 1. I'll get 0, 0, 0, 0, 0, 0, 0, 1. Then I will left shift this for ones and or with 1. So 0, 0, 0, 0, 0, 0, 1, 1. Again left shift it for ones and or with 1. 0, 0, 0, 0, 0, 1, 1 and a 1. So like this, you will left shift and or it with 1. Now let me execute this. I'll make changes. So I save, I build the main project. Okay. So it is giving me a warning because all bitwise operators are performed on integers and port B is actually an unsigned character. So it is giving me a warning. But ignore that. So it is not making any problem. So ignore it and I'm going to file, do the reload last. One second. One second. Oh, sorry. So this has to be 0x00, no, initially. Port B has to be 0x00. Okay. So I'm building the main project. So after that, after the build is successful, I'll go to file and do reload last. Can you see? Turning on the LEDs one after the other. Okay. So actually you have to complete this. Now you have turned on 8 LEDs one after the other. Turned on 8 LEDs. Okay. One after other. So what you have to do next is, as a continuation part of your classwork, next you have to turn off 8 LEDs in the same direction, one after the other. So first the LED of B0 has to be turned off, then the next LED, then the other next LED. So you have to turn off one after the other. And that has to happen on a repetitive manner. That means if you have to see the output, first you have to turn on all 8 LEDs one after the other, then turn off all 8 LEDs one after the other. Again turn on all 8 LEDs one after the other and turn off all 8 LEDs one after the other. So that has to continue. So that should never stop. That has to continue. So turn on all 8 LEDs, turn off all 8 LEDs. Okay. So that is a part of your assignment. In fact, you please make sure you're doing it. Okay. So you should be able to do it. So turn on all 8 LEDs one after the other. In the same direction, you have to turn off all 8 LEDs. Again, turn on all 8 LEDs, turn off all 8 LEDs. Understood? Yes, one by one. Is the classwork clear? And as I said, that's a part of your assignment also. So you should be able to do it on your own. So I will not be doing it. Not 8 to 0, it is 0 to 8. First B0 has to turn off, then B1, then B2, then B3. So from the first LED, it has to turn off. Okay. And this completes LED. One more thing, if you want port D, wherever tris B is there, you have to replace to tris D, and wherever port B is there, you have to replace to port B. But finding the places where tris B is found and port B is found is challenging. So for the sake of readability, you can take a macro. Define, let's say LED array representing port B and Ash define LED arrays data direction register is TRISB. Okay. So in my code, wherever I'm using TRISB, I will use LED array DDR. Wherever I'm using port B, I will use LED array this way. So this is again LED array. This is also LED array. So in that way, I don't have to go search for port B everywhere and do the change. If I want this to work on port D, I just have to change the macro. So instead of port B, I will write port D, and instead of tris B, I will write tris D. So once you change the macro, it is sufficient. You can see the output on port D this time. Observe, I made the change. I just changed the macro. Okay, so this time I want to see the output on port D instead of port B. So I go to file and do the reload last. You can see the output on port D. If you are not able to see, the second DIP should be towards port D. You want to use LED 1, so DIP has to be towards port D. Let me highlight that. So this is the DIP. So it has to be towards port D. Only then you will be able to see the output. Understood LEDs? Everybody, is the LED clear? Okay. So this completes the first peripheral of the module, which is LED. You should be able to do the assignments on LED starting from tomorrow. Okay. So LEDs as based assignments will be given by your lab mentor. Please focus on doing the assignment. If possible today, please complete this classwork which I gave, which is also a part of your assignment. Okay. Fine. So I'm going to stop it here. That is it for today. And from tomorrow, we will start with the next peripheral, which is nothing but digital keypad. So I hope the class is all been clear. Have your attendance marked before quitting the session. Okay. So here is your QR. Please have your attendance marked and then quit the session. Thanks for attending. We'll continue tomorrow. Thank you all.